Okay, so we are now looking, in this lesson, we're going to look at the situation that happens when we get given the graph of the derivative and then we ask questions about the original function. So remember, and we're going to highlight this, this graph that we've got here is not the original function. This is the derivative, the gradient of the original function. Let's see what questions follow here. It says, where is the original function increasing? Now, if it's increasing, what do we want our gradient to be? We want the gradient to be positive. That's what increasing means. And this is the gradient. So basically we're asking, where is f dashed of x? Where's this graph positive? Well, it's positive from -2 to 4. Okay, so the answer will be -2 less than x, less than x, less than 4. Okay, when is the graph concave down? Now remember, for concave down, we want the second derivative to be negative. Now, for the second derivative to be negative, it means that our graph must be going downhill, because the second derivative is going to be the gradient of this graph. When does this graph go downhill? Well, it goes downhill from this point onwards, from 1 onwards. Okay, so concave down for x bigger than 1. Okay, and then it says, what are the x coordinates of the turning points? Well, at the turning points, what do we know about the gradient? The gradient is 0. Okay, f dashed of x equals 0. And we can see, here's the graph of f dashed of x. It equals 0 at 2 and at 4. X equals 2 and 4. Okay, and there's the answer to that one. Right. Remember that if this is the derivative, then the original function must be a cubic function. Okay? And in fact, this cubic function is actually concave up first, and then concave down. Okay, looks something like that, the original function. Okay, then it says give the x coordinate of the point of inflection of f. Now the point of inflection is where the second derivative is 0. It's where the gradient of the gradient is 0. Okay, so now this graph that we've got here is the gradient graph. Where does it have itself have a gradient of 0? That's right, when x equals 1. Okay, now that we've done that question for you, we want you to pause the video and try this one. Okay, and you might notice that this is now sort of slightly different, but similar idea. This is not the function. This is the derivative of the function. Okay, right, let's see if we can answer some questions about that. Pause the video and have a go, and then let it play again. Okay, so for which values of x is f of x negative? Okay, so I think there's an error here, because I think this is saying, where is f dashed of x negative? Okay, where's the gradient negative? All right, and the gradient is negative less than, it looks like about -2.5. Or it's just a little bit bigger than 1, maybe 1,1 up to about 4,4. Okay, so that's where the gradient is negative. Then it says, for which values of x is the function concave up? All right, now the function will be concave up, all right, when the second derivative is positive. Now, this graph, the second derivative will be positive when this graph has a positive gradient. In other words, x less than 1 or x bigger than 3. X less than 1 or x bigger than 3. That's where our derivative is increasing. Then it says give the x coordinates of any turning points. And those will be at these values here because that's where the gradient is 0. So we're just going to use those same values that we used before, negative 2,5 or 1,1 or 4,4. Okay, so x will be equal to those values. Right, and then lastly, give the x coordinates of the points of inflection of f. All right, and now remember the x coordinates of the points of inflection of f are where f dashed of x turns. In other words, where f dashed of x is stationary, because the derivative of this graph will be 0 at these 2 points. In other words, at -1 and at 3. Okay, now we have gone into this in a lot of detail, and we've probably gone maybe a little bit further than might occur in an exam question. But it's all about trying to build understanding for you. Okay, right. So we're now going to look, and it's kind of more of the same ideas. We're going to look at answering questions whereby we need to interpret some graphs. So here we've got 2 graphs, F and G. Right, and we're going to be asked to answer a whole lot of questions about them. Okay, the first one is, where is f less than or equal to 0? Now, when we talk about f of x, we're actually talking about the y value of f. In other words, where does f go below the axis? Okay, and we're going to just estimate, all right? So that looks like about -3,7. Okay, if x is less than -3,7, yeah, let's call that. Let's just write it on there, -3,7. All right? Or this here looks like about 0,2. Anywhere between 0,2 and 5. For all those values, the function is negative. Okay, that question involves no calculus whatsoever. It's just talking about the y value of a function. The next question says, where is g of x negative? Okay, where does this graph go below the axis? Well, when x is less than -2 or when x is bigger than 5. Okay, right. Also no calculus. The next one says, where is f bigger than or equal to g? All right. Where is f bigger than or equal to g? Well, it's bigger than f. So f is bigger than g when x is less than -1. It's above g. X less than -1 or bigger than 5. X less than or equal to -1. Notice, because this isn't less than or equal to, bigger than or equal to, we can include, or x bigger than or equal to 5. In those areas, f is bigger than g, all right? F is above g, bigger than, above. Okay, f above g. Okay, the next one, we still haven't used any calculus. The next one involves a product. A product being negative. Now, how do we get a negative product? We need these two things to have different signs. So in other words, we either need f to be positive and g to be negative, or f to be negative and g to be positive. So there are 2 situations we can look at here. Remember, positive f value means that f is above the x-axis, and we want g to be below. Let's just look at that first. Where is f above and g below? F is above and g is below from -4 to 2. In between -4 and 2, f is above and g is below. Let's see if there's anywhere else where f is above and g is below. Yeah, from 5 onwards, f is above and g is below. But we can also go the other way around. We could have f below and g above. Let's go and have a look now and see if we've got any cases where f is below and G is above. F is below, no, G is below here as well. F is below from here to 5, and at that stage G is above. All right, so from 0,2 to 5. Okay, we still haven't involved any calculus. Now, we're going to do some calculus now. All right, this is talking about the y value of f, and this is talking about the gradient of f. Okay, now, those are two different things, but this time we want a positive product. We get a positive product with them both being negative. All right, what does f of x negative look like? It means f is below. Now, while f is below, we want f dash to be negative as well. All right, what does f dash negative look like? It means going downhill. So we want it below the axis and going downhill. Because if it's below the axis and going downhill, both of those things will be negative and the product will be positive. So let's look at f. Where is it below the axis and going downhill? Well, from 0,2 to 3. All right, 0,2, we can include 0,2 and we can include 3, okay, because we're less than or equal to. And so at those values, we'll get a result of 0. Okay. The other alternative is to have f above, so positive values for the function and positive values for the gradient. Now the gradient is positive, means going uphill. So where is f above and going uphill? Let's have a look. F is above and going uphill between negative 3,7 and negative 2, negative 3,7 to negative 2, or it's above and going uphill from 5 onwards, or x greater than or equal to 5. Okay, now we've got the same question, but now we want a negative product, and now we're talking about G. Okay, so we're going to ask you to pause the video. We're going to ask you just to try this question here. All right, just question F. Remember, to get a negative product, we want that to be positive while that's negative, or this to be negative while that's positive. We can't have either of them equal to 0 because we want to be less than 0. Pause the video and have a go, and then let it go and see how you did. Okay, so G positive means above. So we want G to be above the axis. That's what a positive value looks like on G. And downhill. It's because we want the gradient to be negative. Let's just see, where is G above the axis and going downhill? Well, it's basically from 3/2 to 5. Above the axis and going downhill. 3/2 to 5. Or, I'm using a different color pen now. We want it to be below, but we want the gradient to be positive. So in other words, below and uphill. Let's have a look where it is below and uphill. We're talking about G. It's below and uphill to the left of negative 2. X less than negative 2. Okay, the next one involves concavity. Second derivative negative. That means like concave down, sad. Okay, concave down like a frown. Okay, so where is F concave down like a frown? Let's have a look at that. Well, there's F. It starts going concave down. So it is concave down up to a half. Everywhere less than a half, it's concave down. So X less than a half. All right. This is h double dashed. We don't have an h, that's rubbish. That should be g double dashed of x. Where is the second derivative? Where is g concave down? Sorry, not concave down, concave up, like a cup. Let's have a look at the graph of g. G is in fact concave down, always. Okay, so no solutions. There's nowhere where g is concave up. Right, this one. This is a product of f and the second derivative. And we want it to be positive. Now remember, positive means they both have to have the same sign. Either both positive or both negative. F positive means above. So we want f to be above while the second derivative is positive. So at the same time as being above, we want f to be concave up. Let's just see, is there anywhere where f is above the axis and concave up? Yeah, from here, no, it's concave down. Okay, above the axis and concave up, no, it only becomes concave up from here. So, and it only goes above the axis from 5. So x bigger than 5. And in fact, we can actually include 5. All right, the other possibility here is to have f below, that'll be a negative value, and the second derivative negative, because then we'll have two negatives, which will make a positive product, and concave down. Okay, f below and concave down. F is concave down here, but it's above at this, oh, okay, below and concave down, less than -4, less than or equal to -4. All right, concave down, still concave down, it goes below between 0,2 and a half. Over here on this tiny little piece here, it's below and it's concave down. Okay, thereafter it's concave up. So from 0,2 to 0,5. Okay, right, now let's take a look at this last one. This one is a fraction. Now just be careful. A fraction is 0 when the top is 0. The bottom may not be 0. So we can't include the point of inflection. But a fraction is just like a product in the sense that to get a negative result, we either need a positive on the top and a negative on the bottom. And let's just talk about what that looks like. What does a positive gradient look like? It means that f must be going uphill. Okay, but we want the bottom to be negative. So uphill while concave down, because if the second derivative is negative, the graph is concave down. Let's go and have a look. Where is f going uphill while it's concave down? Okay, well, it's only concave down up to here, and it's only going uphill up to -2. So x less than or equal to -2. X less than or equal to -2. Right, but the other possibility is for this one to be negative and this one to be positive. And that would be down, going downhill while concave up. Okay, so like a cup, but going downhill. Let's have a look. We're talking about f. Like a cup, it goes downhill. It becomes like a cup at a half, and it goes downhill until 3. Right, but we cannot include the half. The reason we can't include the half is because the second derivative would be 0. So we're going from a half to 3, but we're not going to include the half, because the half would give us a 0 underneath, undefined. Okay, so a half less than x less than or equal to, I think I said 3, did I? Yeah, 3. Okay, all right. Now that was quite heavy, and again, just loads of opportunity to try and improve your understanding of this stuff. Okay, next time we're going to dive into something probably slightly a little bit easier, and we'll look forward to seeing you then. Okay, bye now.